Welcome to Eureka Math. I'm Mr. Shankel. Going to be helping you today with Module 4, Lesson 13. Let's get started. Okay, so we're going to find, I think there's 10 examples here, 10 ordered pairs from the linear equation 3x plus y equals negative 8. Hopefully you'll recognize that this linear equation is in standard form, ax plus by equals negative 8. And so we just need some examples, and I'm going to start with 0, and we'll see where that takes us, okay? So let's start with 0. If we put a 0 in for x, 3 times 0 is 0, so we get y equals negative 8. Okay, if we put a 1 in for x, we get 3 times 1 is 3 plus y equals negative 8. We would have to subtract 3 from both sides. That gives us y equals negative 11. Let's go with a negative number already. So we're getting big on our y values, or small actually on our y values. So let's go with a negative 1. If we put a negative 1 in, we get 3 times negative 1 is a negative 3 plus y equals negative 8. I would have to add 3 to both sides. That gives us a negative 5. Let's check a negative 2. 3 times negative 2 is a negative 6 plus y equals a negative 8. I would have to add 6 to both sides. That gives us a negative 2. If I put a negative 3 in for x, that would be a negative 9. 3 times negative 3 is negative 9. Plus y equals negative 8. If we add 9 to both sides, my y is now a 1. Let's keep going with the negatives. Negative 4 times 3 is negative 12. Plus y equals negative 8. Add 12 to both sides, that would give me a positive 4. Negative 5 in for y, we get 3 times negative 5 is negative 15, plus y equals negative 8. Add 15 to both sides, I get a positive 7. And let's do another one. Negative 6 times 3 would be a negative 18, plus y equals a negative 8. And if we add 18, we get y equals 10. And I'm gonna stop there because those will fit on my graph nicely. So let's just plot those and see what kind of line we get. 0, negative 8. That's going to be right here. 1 to the right and 11 down. Let's see, did I get that right? 1, 2, 3, 4, 5, 6, 7. No, I got to go one more down. There's negative 8. And then 1 to the right and 11 down, we actually go off our coordinate plane a little bit. So left 1 down 5 would be here. Left 2 down 2, left 2 down 2 would be here. Left 3 up 1 is that one. Left 4 up 4 is here. Left 5 up 7. Left 5 up 7 is right there. And left 6 up 10 is all the way up here. And let's connect those dots. And we've got a line. That is the line of the linear equation 3x plus y equals negative 8. All right, if I kept going, I could put more positive numbers in, but obviously when I made a positive number, my y value for x just got really small. So if I chose a 2, for x, 2 times 3 is 6 plus y equals a negative 8, and I would have to subtract 6 from both sides, and I got a negative 14. It's just going to be on the same line but farther down. If I chose a 3, then the same thing. 3 times 3 is 9 plus y equals a negative 8, and subtract 9 from both sides, I get a negative 17. So the farther I get in my positive x values, the smaller my y value. In fact, it went way below the space on my coordinate plane. So we could continue to do this to infinity. There are an infinite number of possible x values that will create an infinite number of possible y values, and so therefore we would have an infinite number of possible ordered pairs. Okay, that's the first one. Let's do another one. the linear equation now is x minus 5y equals 11. So let's put a 0 in for y this time, because my y has the coefficient. So if I put a 0 in for y, I just get x equals 11, because negative 5 times 0 is 0. I'm left with x equals 11. Now let's try a couple of positive numbers. X minus, that's an x, minus 5 times 1 equals 11. So that's x minus 5 equals 11. X minus 5 equals 11. I would have to add 5 to both sides, and I get x equals 16. So already my x's are getting pretty big. Let's do maybe one more. Let's put a 2 in for y. If I put a 2 in, I get x minus 10 equals 11. I'd have to add 10 to both sides, and if I do that, I get 21. So my y values are getting a little bigger than I want, so I'm just going to go to the negatives. If my y value is a negative 1, I would have x plus 5. Negative 5 times negative 1 is a positive 5, so x plus 5 equals 11. Subtract 5 from both sides, I get x equals 6. Let's put a negative 2 in there. X plus negative 2 times negative 5 is a positive 10 equals 11. And if I subtract 10 from both sides, I get x equals 1. If my y value is a negative 3, x plus 15 equals 11. Subtract 15 from both sides, I get a negative 4. If y is a negative 4, I would have x plus 20 equals 11. Subtract 20 from both sides, I get a negative 9. For x, if y is a negative 5, I would get x plus 25 equals 11. Subtract 25 from both sides, and I get a negative 14. And we can maybe do one more. Let's put a negative 6 in there. X plus 30 equals 11. Subtract 30 from both sides, and I get a negative 19. All right, so we got some bigger x values and smaller x values, a wide range. And let's plot them and see what we get. X11, let's count by 2's on every line here so we can fit these in. So this would be 10, and 20 would be all the way out here to the edge, and this would be a negative 10, and this would be a negative 20 all the way out here. And my y values will just count by 1's. All right, let's see what we get. 11, 0, 11 to the right and 0 up, that's going to be right there. 16 to the right, 1 up. Well, 12, 14, 16, and 1 up is right there. 21 to the right and 2 up. 21 to the right is a little bit off my grid, but 2 up is right there. And then we went left 1, 6 up. 6 to the right and 1 down. 6 to the right and 1 down. 2, 4, 6, and 1 down. That one's right there. 1 to the right and 2 down. 1 to the right and 2 down is that one. Left 4 and down 3. Left 4 and down 3 is here. Left 9 and down 4. Left 9 and down 4 is that. Left 14 and down 5. Left 14 down 5 is there. Left 19 and down 6. Left 19 and down 6 is that one. All right, so here's our line. That is the line for x minus 5y equals 11. Okay, Joey predicts that the graph of negative x plus 2y equals 3 will look like the graph shown below. Do you agree? Well, I don't. I haven't seen a line like that in the last 2 lessons, so I'm guessing no, that's not going to be right, but let's check it. Let's put some values in for x and solve for y. So let's say x is a 0. I'd put a 0 in for x, I'd get 2y equals 3. So I'm just going to write that down here, 2y equals 3. I would multiply by the reciprocal on both sides, and that cancels the 2's. I get y equals 3 halves, that's 1.5. So y equals 1.5 if x is 0. And instantly I see a problem, right? His point for x equals 0 is y 0. That's right here, and that's not right. Because when I put a 0 in for x, I got a 1.5. So 1.5 should be that point. And then look, we've got a line. If we line up his points, his other points, and the one that we put in, we do get a line. And so it should, he's wrong. Joey's wrong because he had one of those points off the line. It should have been the ordered pair 0, 1.5. And that is the line for the linear equation, negative x plus 2y equals 3. All right, that is lesson 13. Hope that helps. See you next time.